Okay, now we'll try number 4. Given the distribution blah 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 blah, test whether the results are uniformly distributed. So uniformly distributed would mean that things are kind of equally spaced amongst all the different values that are occurring. Let's open up the calculator. I think it's the same calculator as last time, but now we're not going to be given a matrix of possibilities. We're going to be given what's called a Goff test, or a goodness of fit test. So in this case, we are given certain information. We want to see if it conforms to our expectations. So for example, well, let's put some numbers in here: 12, 13, 12, 12, 5. And we need to see if that goes with the expectation of 14, 15. We expected. So they're off by a little bit, but are they off by enough? And it calculates some things. Actually, I'm missing one here because they have to add up to the same amount. So there we go, 54. You get chi-squared score, p-value. Okay, getting numbers working around. Let's say that all these numbers are going to add up to, let's go 0, 0, 0, 0, 20. And if they're going to be evenly distributed, I have a total of 20 in this row. So in 5 groups, that means it should have been 4, 4, 4, 4. And then that would still, they would add up to the same amount of 20, but now all of a sudden these ones are all kind of ridiculously off, and then this one's really off. And notice the chi-squared score is extremely high, and the p-value is essentially 0. So that's how these ones are kind of pacing out. So let's come over and make up a problem for ourselves. Okay, let's say I roll a die something like 60 times. I get the results of, okay, so 60 times, let's say I get 12 ones and then 15 twos and then something like 8 threes, and then I get something like 5 fours, and then I get like 11 fives, and I get something like 9 sixes. So notice that these results here, 1, 2, 3, 4, 5, 6, if I rolled it 60 times, there's 6 sides on a die, so I should get about 10 in each one. So some of them are above and some of them are below, but are they significantly above or significantly below? Because when we roll a die, we don't really get the same number of results every time. You know, things go kind of random. Random is as random does, as Forrest Gump would say. So what would I expect to happen? I would have expected, if they were uniformly distributed, 10 of each. Right? That's what should have happened here. So let's run a hypothesis test. And the hypothesis test in this context might be something like h sub 0. Essentially, if they're evenly distributed, that would be the hypothesis, right? Evenly distributed, which would be like saying sort of the die is fair, versus an alternative that might say something like h sub a, not evenly distributed, not uniformly distributed, to use the word we used in the quiz there, not uniform. And of course, if they were not uniform, that would indicate somehow that the die is somehow biased. It's not fair. So I'm going to, just like usual, have to run a test here, and the test is going to give me a chi-squared score. And after it does that, it's going to give me a p-value, and then based on that, I'm going to make a conclusion. So let's come over here. Nicely, this one's still in. I have to clear all the old data. We know it's supposed to add up to 60, so when we put these in, oh, I can reset all. Oh, that's a lot easier. I've got to play with the calculator to learn how to use it, eh? So the observed would have been this 12, and then 15, and then 8, and then 5, and then 11, and then 9. And I should have been expecting 10s across the board if they were evenly distributed in each one of the categories. So calculate, and let's go over and see what we got. Rows add up to 60. Excellent, just like I was hoping. Chi-squared score is around 6. We can go over here, put in a 6. My p-value is a 0.3062. And so that, of course, is not a rare p-value. That's not less than, that is bigger than 0.05. So that means I'm going to have to fail to reject the null. I do not have evidence Even though these numbers up here are not 10, 10, 10, 10, 10, 10, I do not have evidence that the die is somehow biased. It seems like things are lined up exactly, are close enough to reality, close enough to expectations that I don't have a significant difference from that. So I do not have evidence that the die is biased.